Alright, welcome to another draft physics video production. Such. Yeah, anyway. So first in a probably series of videos, just asking a simple question. Here's an alternative explanation. Why can't it be true? What evidence is it incompatible with? What facts? What things that we really know versus things they say we know. Yeah, that worked out well. Almost. Anyway, I'm not going to start over. So there's this cosmic redshift, and it's used as a reason to believe the universe is expanding. And combined with the cosmic background radiation, which I never really understood as an explanation for the Big Bang. But here goes. We'll try to say, first we'll do the background radiation, try to make sense out of it. So the idea is that the universe was some little thing, and it exploded. Now, my first thing I would say is well, it's supposed to have exploded as a bunch of energy. So all of this stuff would be moving the speed of light. Let's say that's how light was created. That's how force was created, was the stuff moving really fast. But then that doesn't work, because why would any of it ever hit each other? And it wouldn't have enough gravity to overcome its momentum, so it would just keep going, and that would be it. There'd be nothing. So there has to be chunky pieces, or what's called matter bits or something, that have to be in this idea of a bang. So there has to be electrons and protons and heavier things that can't move the speed of light and are moving much slower. And I suppose the theory is that the explosion again the stuff that left the speed of light somehow wouldn't leave the speed of light ahead of this stuff, and somehow would be behind it, pushing it, or in some other way reflecting off of it, and somehow, getting caught, and then finally gets out somehow. And then so later on, when you're in the universe way over here in time, you've gone, say, 13 billion, you've waited 13 billion years, and you're some distance from the explosion, that somehow this explosion has gone all the way around you. There's matter 13 billion light years away in all directions, and this is still reflecting some sort of energy, this that we'd call the cosmic background radiation, and you'd see the same amount of it from all directions. It just, you can't really make any sense out of it. I mean, if it was a Big Bang, then there would be a visual signature, in the sense that you'd expect that after 13 billion years there wouldn't be an even distribution of energy, because there's no reason for there to be, for something that wasn't in the center looking out. I mean, you could sort of say that if there was a bunch of these matter bits out here in the distance, and it was reflecting the energy from the original bang back, and you were here, that well, even that doesn't make any sense. So frankly, I just couldn't make much sense out of how background radiation would be evidence of an explosion, because where would you have to be for you to see that? So I thought maybe if it was a smoke ring, like there was an explosion and there was a smoke ring, and we were somehow in the smoke ring, well then every way we looked there would appear to be energy, but it still doesn't really make that much sense to me. So I don't find that a terribly persuasive argument that background radiation demonstrates that there was a bang, an explosion, because it just doesn't explain why it's even, this pressure, this light. Now I would argue that the background radiation, which you could just visualize as coming from some outside location, and you're in here somewhere, and it just keeps on coming. So in a sense, the universe is in a bubble, and all the energy that hits the outside of the bubble comes back as what you might call unprocessed. So if it hits the bubble with a frequency, it leaves without a frequency. It leaves back in little pieces. And that would be gravity, because this would be a constant pressure that would be constantly reflecting off the outside of the bubble. So all the thermodynamic problem is solved in the sense that any of the energy lost to the free universe, like say all the planets and galaxies, all that crap is in here somewhere. And so all the light and energy that's going out this way, the magnetism, all that stuff, would be reflected back as gravity. Something like that. So that explains it. It's not a, there's no way to prove it, but at least makes an argument for why this radiation is coming from the outside in. And that's the important part, I guess, is that it's from the outside in. And an explosion would create energy. Frankly, an explosion would create energy you couldn't see, because the energy is going faster than you. So it zooms right past you, and then you can't see it because it's got to reflect off something to get back to you. And what's it reflecting off of? So again, you're back to this argument. It's got to reflect for you to see it as the explosion. It's got to reflect off something ahead of you, not something behind you, so to speak. All right, anyway. Sorry, I wanted to get to this redshift argument. Okay, so I would say, so their explanation for cosmic redshift is they're basically saying it's sort of like there's, you can make this argument about velocity. Two things could have a velocity in this direction of, say, 50 miles an hour. Let's say something like that. But their total distance, if measured this way, would appear to be a faster speed. So if you measured the rate at which they are receding from each other, this rate seems bigger. I mean, it's just a simple argument that if one thing travels this way and one thing travels this way, the net is 100 miles per hour, all right? That they appear to be leaving each other at as total. If we don't care who's moving, the fact is that the two objects will be moving that many miles in an hour away from each other, even though they're only going 50 miles an hour each. So that's sort of a problem, okay, because there's neither one of them has the velocity to justify that speed, but that's the actual distance they're going to be from each other, just a fact. So there's this idea that space is expanding, that somehow space has this problem. I mean, in terms of, say, we're the Earth here viewing some distant galaxy, it appears to be recessing from us at this very fast speed. Now, the problem with that theory is that if it was actually moving, it has to actually be moving to be causing redshift. I mean, it can't, well, I guess technically it's a kind of movement. I don't know. I mean, I didn't think it through to say what would happen to a frequency, energy sent this distance. It still has to travel this longer distance, and that's just a fact. A longer distance than justified by any of the speeds the two things are traveling. So, anyway, that's not even their theory. I'm just pointing out how this creates a problem in measuring actual speed, is that two things can be moving away from each other even though neither one of them has the velocity to justify the distance. So velocity isn't the only consideration. You have to consider what dimension the velocity is in, what angle, what direction. Yeah, direction is the simplest way to say it. All right, so the other point is this, okay, so they have a thing in space, and then we're here viewing that thing. I guess I might as well draw that as an eyeball when you're doing the viewing thing. It's not much of an eyeball. Yeah. Anyway, it's got some corneal problems. Needs corrective glasses, no doubt. Anyway, so we're viewing objects and they appear to be redshifted. That is their frequency of their light. The light they should be emitting has been retarded in the sense that it's been expanded. The frequency is larger than it should be. The separation between the pulses of light, however you want to say it, to placate the etherists or whatnot. The feature that identifies the light's frequency is stretched. And the assumption is that the object has to be moving away or moving. Now, we don't know our relative position. We don't know which way we're moving. We could be moving in all kinds of directions and causing some of that perceived change in the normal wavelength of the light. The normal wavelength has been stretched. And so either we're moving away or they're moving away, and they come up with really fast speeds. I mean, some of this stuff ends up being like 3/4 of the speed of light or something, that some galaxy is moving. I mean, an insane speed when you consider how hard it is to move matter. Velocity isn't that easy to get. You have to get it by some force pushing you, basically. And, it requires a force to act on you. And so where does it get all the force to gain of this huge velocity in, say, one direction anyway, away from us? Away. So that's the problem they come up with. Well, which way? And so then they say that space itself is expanding to justify this velocity. They say that space is being injected into every location in space, and in between these little pulses of light there's new space being made, and the new space is what's pushing the frequency. Now, I just say, okay, that's a nice made up thing. You're generating new space. You have no evidence of something that can generate space. So it's almost like saying the Invisible Man did it. I mean, it works if you believe in invisible men, but it's not much of a physical explanation. All right, so start over again. So I would propose that a possible explanation for the fact that the shift has changed, that there's a, that that the light has been stretched, would be that if you have the two objects, and so the thing to understand is that when what we're seeing is light, and I would argue, and it's just the period is the important part, the fact that there's a period between, amount of time between the light. So the light is leaving this object. We'll just draw it in blue. We'll draw a light as just a little dot. Why not? And I would argue that this dot has to travel great distances. So what the whole point of the redshift is there's more redshift the further away something is. So I should have pointed that out. So the conclusion is that the so the further away it is, the more this light is spread out. And so that's the space argument, that space keeps expanding, and so the further away you are, the more expanded space you'll end up creating between you and something else, because there's going to be more time. It'll take more time for the light to get there, therefore there's more time for space to keep popping new blobs of space in between these bits of energy. These perturbations in the ether, this light wave. Alright, so my argument would be is that no, what's really happening between things at distance, at great distances, this is billions of light years, billions light years. Well, you get the point. Billions of light years away. And what's really happening is there's a bunch of little atoms spread in space. There are some that are just disassociated. They just are flying through space from previous supernovas and whatnot. They have and they are moving, generally speaking. I'm not saying some can't be perfectly stationary, but they're generally speaking moving in a direction because they came from someplace that exploded, someplace that had an event happen. So space is full of those in the sense that, okay, they're not like, you can't just take a bucket and scoop up a bunch of them, but they're there. So if you took a net and you know, you could catch them, and mostly hydrogen. So little hydrogen atoms, and some helium. That'd be the second one. So these are transparent atoms. So they're atoms through which light travels without disturbance. It doesn't get messed up when it travels through one of those atoms. So if it was going in a direction, it keeps going in that direction. It doesn't get ruined by the experience. It doesn't reflect primarily. That's the biggest point. It doesn't reflect. So the logical argument is that if light's traveling and it hits one of these atoms, then it'll be transmitted through it, but there'll be a consequence depending on what the velocity of the little atom is. So if the hydrogen atom is moving against, which is more likely, you're more likely to hit something going the opposite direction than the direction you're going. It's hard for a piece of light to hit light. And it's hard for an atom to catch up to light and hit it from behind. You know what I'm saying? So if something's moving through this field, the point is it's going to hit more stuff, logically, going against the direction it's going, than it's going to hit stuff going with it, because it's going faster than this. It's going the speed the stuff could ever. The point is, nothing could ever catch up to it, or certainly nothing could crash into it, and especially not a photon. Nothing's going to go fast enough to plow into the back end of a photon, but certainly it'd be easy to hit stuff coming at you in some direction, some vector, some that has a component in the opposite direction to your travel. So you're more likely, look, it's just a point that everybody should know, you're more likely to hit stuff coming at you than going with you, with a component against you than a component with you. So you're going to hit atoms that are going to, more atoms that'll be going against you. And what's the consequence of going through a transparent atom going against the direction you're going? Well, the consequence is going to be that essentially the atom is going to readmit the photon. It's in a sense, it's going to, the force will travel through the object, and there's always a slowdown that's noticed, 40% in water and glass, where the transmission speed is much slower for the light. So we know that that alone could account for it, just that idea of just understanding it as a speed equation. But more importantly, the point is that when force goes into, when light goes into an atom, its force, the force does travel through the atom, but it doesn't travel through the atom as if it was free. It travels obviously by doing some, going through some process. I would argue the process is interacting with an electron, and the electron moves a distance and then readmits the photon. You know, so it absorbs it in one position, it readmits it when it's in another position, and that's basically the function of energy through an atom. So the point is if this atom is moving in this direction, then the electron movement won't represent the movement, okay, that the photon imposed, because the electron already has a momentum against. And so essentially, you know, the input energy will hit the electron, and the electron will essentially end up in a backward position from where it was when the photon hit it, and that's where the new light will be emitted from. So the new pulse, so the pulse goes into the atom here as a pulse, and then the readmitted light doesn't leave from that position or from forward position, it leaves from a negative position. So the light goes in here and it leaves in this retarded position, and that is what's causing the redshift, because now the frequency goes in and the next photon will be produced in a retarded position from the original, and so that will cause the shift, because you're basically, this travel is happening between these two pulses. So they should be this close together, but because the atom is moving, the readmitted the next pulse will be retarded. It'll be slowed down, or it'll be retarded in the sense that it'll lose some distance in this direction and then be readmitted from a position that's going to be this has already traveled this way. I don't know. Yeah, I think you get the point. You should be able to get the point. The point is that this momentum that it's fighting against is going to end up stretching the distance between the pulses. So the simple argument would be is the further away something is, the more likely it's hit some atoms on its travel, the more likely those atoms are traveling against it, and the fact that they're traveling against it creates a Doppler shift and does a little bit of stretching. So that each atom it hits does a little tiny bit of this stretching, and the further away you are, obviously the more stretching you end up having and the more shifted you are. So this explains why very distant objects are redshifted, is because they're traveling through a lot of empty space that isn't completely empty, and they're inevitably hitting some of the particles that we know exist in that empty space. So why can't that be the explanation? No expanding universe as a consequence, no preposterous real speeds of objects, because they're basing the speed based on the redshift, assuming that the shift in the light is because of the speed of this object in this direction, and not accounting for the fact that no, the shift is being caused by a bunch of little things with this direction. So the speed that they're calculating is this combined speed of all of these atoms that the light would have to travel through, not the real speed of this object. It didn't emit the broken light. The light was broken as it traveled, and so this object isn't traveling anything like those crazy speeds. Right. So what's the evidence saying this can't be the right answer? Why can't this be an explanation just as correct as the other explanations, in the sense that we don't have much evidence? I mean, besides the existence of the redshift, and the whole point is what theory explains it and has the simplest answer, the more realistic. So I argue that there's everything. It's very realistic to understand there's atoms in empty space. It's realistic to think they transmit light because they're transparent atoms, and it's realistic to recognize that that would change the character of the light, and explain why there's a relationship between distance and redshift. And this really isn't about the velocity of the objects we're looking at. It's about the velocity of the bits of matter the light had to travel through to get to us as a destination. I don't know why this red is so hard to erase. Well, it's not that hard, but I mean, relatively speaking, it's a bitch. So anyway, I think that's enough. And so, yeah, so if you have an explanation, provide it. If all you have is some kind of insult, don't bother wasting your time, because I'll just delete it. So the only thing I'm looking for is a counter argument. Why can't that be true? Is there some other piece of evidence that proves that redshift is caused by creation of space, either the creation of space between photons, or some notion that the emitting body is actually traveling 3/4 the speed of light? Is there some other way to figure out how fast something's moving besides measuring shift? All right, so enough. Could have been done better, but you'll have to do. Yes. Till next time. Such, keep it brief. It wasn't brief enough, but There was an effort to keep it